Hello, my dear children. How are you? Now, come to the exercise 4.6. In this exercise 4.6, we use applications of determinants and matrices. Okay, my dear children. In this exercise, we use determinants concept and also matrices. In this section, we will discuss application of determinants and matrices for solving the system of linear equations in two or more variables and for checking the consistency of the system of linear equations. In earlier classes, you have studied how to solve a system of linear equations, a pair of linear equations in two variables. Now we use the concept of matrices and determinants to solve the system of linear equations. Okay, my children. And also we use these concepts to check the consistency of the system of linear equations. Okay, my children. Now let us define what is meant by consistent system of linear equations. A system of linear equations is said to be consistent if its solution, one or more, exists. Suppose linear equations are given, two or more linear equations are given. If we are able to find the solutions to the system of linear equations, if the system of linear equations have solution, then the system of linear equations is said to be consistent system. Understood this definition, my dear children? Right. Now come to the second point. Inconsistent system. Let us define inconsistent system. Okay, my dear children? Right. A system of equations is said to be inconsistent if its solution does not exist. Understood this definition, my dear children? Inconsistent system. If the system of equations does not have any solution, then the system of equations is said to be inconsistent system. Now come to this point. Note this point. Remember this point. In this chapter, we restrict ourselves to the system of linear equations having unique solutions only. Remember this point. In this exercise, we get some solution for the given system of equations. Okay, my dear children. Now come to the point number 3. Solution of system of linear equations using inverse of a matrix. Now we are going to discuss about the method to find the solution of system of linear equations using the inverse of a matrix. Let us express the system of linear equations as matrix equations and solve them. Okay, by using the inverse of a matrix. Now there are different stages in solving the system of linear equations using the inverse of a matrix. First of all, we have to express the system of equations as matrix equations. Then we solve them using the inverse of the matrix. Okay, my dear children. Consider the system of equations. Now let us take the system of linear equations in three variables like this. A1x plus b1y plus c1z is equal to d1. This is one equation in the variables x, y and z. Second equation a2x plus b2y plus c2z is equal to d2. This is another equation in the variables x, y and z. Okay, my children. Now a3x plus b3y plus c3z is equal to d3. This is a third equation in the variables x, y and z. What will you find here? What are the variables here? X, y and z only. Understood, my children? Now we write the above system of linear equations in the form of matrix equations as follows. Okay, my children, we use the matrix concept to solve this system of linear equations in the three variables. Now let A is equal to a1, B1, C1, A2, B2, C2, A3, B3, C3. X is equal to X, Y, Z. B is equal to D1, D2, D3. We write these three matrices. This is the first stage. Okay, my children. In the first stage, we write the given system of linear equations like three matrices. First matrix is A, second matrix is X, and third matrix is B. Here A is said to be a coefficient matrix because A1, B1, C1, A2, B2, C2, A3, B3 and C3 are the coefficients of the variables X, Y and Z in the system of linear equations. If you observe these three equations, A1, B1, C1, A2, B2, C2, A3, B3, C3, these 9 elements are the coefficients of the variables X, Y and Z. Isn't it or not, my dear children? Yes. Okay, my dear children. Understood? Right. Here matrix X is said to be variable matrix as X, Y and Z are three variables in the system of linear equations. You know the letters X, Y and Z are said to be variables. That is why this matrix X is said to be a variable matrix. Okay, my children, understood this one? Now come to the matrix C. Here the matrix C is said to be a constant matrix as D1, D2 and D3, D1, D2 and D3 are the constants given in RHS of the system of linear equations. If you observe the given system of linear equations, D1, D2, D3 are the constants given in RHS. Okay, my children, that is why the matrix C is said to be a constant matrix. Understood these 3 points, my children? Right. Then the system of equations can be written as Ax is equal to B, that is, here I wrote matrix A1, B1, C1, A2, B2, C2, A3, B3, C3 into X variable matrix X, Y, Z is equal to B, that is constant matrix D1, D2, D3. This is the second stage. Okay, first of all we have to identify what is a coefficient matrix and what is a variable matrix and what is a constant matrix. After that we have to write the system of equations in this form: Ax is equal to B. Okay, my children, this is a second stage. Now the third stage, case 1, if A is a non-singular matrix then its inverse exists, means here we have to find its determinant whether it is a singular matrix or non-singular matrix. This is the third stage. We have to find its determinant. If det is not equal to 0, the determinant of the matrix A is not equal to 0, it is said to be a non-singular matrix. Then its inverse exists. We know for non-singular matrices only inverse exists. Now in this case we take this equation, matrix equation. This is called matrix equation. Ax is equal to B. On both sides we are multiplying by A inverse. Pre-multiplying means here first here also first factor. So A inverse into Ax is equal to A inverse into B. Understood this equation, my dear children? Right. Okay, my children, understood this equation: A inverse of A into X is equal to A inverse into B by pre-multiplying the equation, the above equation by A inverse. Then we get A inverse into X is equal to A inverse into B by associative property. By applying the associative property in the above equation, in the previous equation, we apply associative property, then we get this equation. Understood, my dear children? Right. This implies A inverse into A means I. Inverse of a matrix into the matrix itself gives identity matrix into X is equal to, we write RHS part as it is, that is A inverse into B, because A inverse into A is equal to identity matrix. I means here identity matrix. Understood this step, my dear children? Right. This implies X is equal to A inverse into B because identity matrix into a matrix is equal to the matrix itself. Okay, my children. Same like in the case of numbers. 1 into any number gives the same number itself. Similarly, here also identity matrix into any matrix gives the same matrix itself. Understood this step, my dear children? Right. This matrix equation provides unique solution for the given system of equations as the inverse of a matrix is unique. Here inverse of the matrix is unique. So the system of equations, in this case the system of equations has a unique solution. This method of solving system of equations is known as matrix method. What is this method said to be? Matrix method. Now come to the case 2. Second case. If A is a singular matrix, what is meant by a singular matrix? The determinant of the matrix is 0. In this case, we calculate adjoint A into B. Okay, my children, this is the third stage. In the third stage, if A is a non-singular matrix, we follow this method. If this is second case, if A is a singular matrix, we follow this method. That is adjoint A into B. We have to calculate this matrix. If adjoint A into B is not equal to 0, 0 means here a 0 matrix, then solution. So in this case 2, we calculate adjoint A into B. If adjoint A into B is not equal to 0, where 0 means a 0 matrix, then the solution does not exist and the system of equations is called inconsistent. In that case, if you get adjoint A to B is not equal to 0 matrix, then the system is said to be inconsistent. Next, if adjoint A into B is equal to 0, if we get a 0 matrix, then the system may be either consistent or inconsistent according as the system have either infinitely many solutions or no solution. If it has infinitely many solutions, it is said to be consistent. If the system does not have any solution, in that case, it is said to be inconsistent. Understood these points, my dear children? These are the points we have discussed for the exercise 4.6. Okay, my dear children. Now come to the question number 1 in the exercise 4.6. Examine the consistency of the system of equations x plus 2y is equal to 2, 2x plus 3y is equal to 3. Here a system of a pair of linear equations is given. We have to find this system of equations is consistent or not. For that, we write the given system of equations in the matrix form, matrix equation. The given system of equations can be written as the form Ax is equal to B, where here we are writing the given system of equations in the form of matrix equation Ax is equal to B, where A is equal to matrix 1, 2, 2, 3, x is equal to matrix x, y, b is equal to matrix 2, 3. This is the first stage. I told you clearly. We had to find out what is a coefficient matrix, what is a variable matrix, and what is a constant matrix. This is the first stage. After that, we have to find determinant of the matrix A. We are finding the determinant of the matrix A. Det 1, 2, 2, 3. You know this is a matrix of order 2 by 2. And you know how to find the determinant of a matrix of order 2 by 2. Just like a cross multiplication. 1 into 3 minus 2 into 2. Understood, my dear children? Right. Now we simplify these terms. That is equal to 1 into 3. What will you get here? 3 minus 2 into 2. What will you get here? 4. Understood this equation, my dear children? Right. That is equal to 3 minus 4. What will you get? Minus 1. Okay, my dear children. Now we have to identify whether this number is a 0 or a not non-zero number. Actually, this is a non-zero number. Isn't it? Right. Hence, the system of equations is consistent. Here, we got a non-zero number. Delta is not equal to 0. Therefore, we can say that the system of equations is consistent. That's all. That is enough. No need to find here solution to the system of equations. Just we have to check the given system of equations is consistent or not. Understood, my children? Right. Now come to the question number 3. Examine the consistency of the system of equations x plus 3y is equal to 5, 2x plus 6y is equal to 8. Here also a pair of linear equations in two variables x and y is given. Okay, my children. Here also we have to write this system of equations in the matrix equation. The given system of equations can be written in the form Ax is equal to B, where A is equal to matrix 1, 3, 2, 6, x is equal to x, y, and B is equal to 5, 8. This is the first stage. I told you clearly, my dear children. A means coefficients of x and y. X means variables in the given system of equations, and B is the constants in RHS. Okay, my children, understood this part, this stage, right? Now we find det A. We are finding the determinant of this matrix A. So det 1, 3, 2, 6. We follow the same procedure what we followed here. We follow the same procedure. 1 into 6 minus 2 into 3. What will you get over here? 1 into 6, 6 minus 2 into 3. What will you get here? 6. 6 minus 6. What will you get here? 0. Here, det A is equal to 0. Okay, my dear children? Understood? Right. Then what will you say about A? A is a singular matrix because det A is equal to 0. Okay, my children. Now we calculate adjoint A into B because delta is equal to 0. We can't decide whether the given system is consistent or non-consistent, inconsistent. Okay, my children. Now we find adjoint A. You know how to find adjoint of A 2 by 2 square matrix. In this diagonal, we have to interchange the elements. In this diagonal elements, we change the sign. Remember that point, my dear children. I have explained in the case adjoint of a matrix of order 2 by 2. Now come to the matrix B 5, 8. Now we have to multiply these two matrices adjoint A into B. So matrix 6 minus 3 minus 2 1. Okay, my dear children, 5, 8 matrix B. So here adjoint A is of order 2 by 2 and B is a matrix of order 2 by 1. Then what will be the order of the matrix adjoint A into B? 2 by 1. In the rough work I have done this one. So the resultant matrix is a matrix of order 2 by 1. Now you know how to multiply two matrices. Recall that previous knowledge. So 6 into 5, we take first row and here first column. So 6 into 5, we keep here plus sign, minus 3 into 8. We multiply the corresponding elements. First element here, second element into second element. Understood this one, my dear children? Right. Now come to the second row. We take second row and here first column. Again here also we multiply corresponding elements, means here first element into first element. So minus 2 into 5, we keep here plus second element into second element, 1 into 8. Understood this line, my dear children? Right. That is equal to, now we simplify these terms. 6 into 5, what will you get here? 30 minus 24 minus 3 into 8, what will you get here? Minus 24. Now come to this line, minus 2 into 5, what will you get here? Minus 10 plus 1 into 8, what will you get here? 8. Understood this step, my children? Right. That is equal to 30 minus 24, what will you get here? 6. 10, minus 10 plus 8, what will you get here? Minus 2. If you observe this matrix, it is not a zero matrix. Okay, my dear children, we got here adjoint A into B is not a zero matrix. Hence, the system of equations are inconsistent with no solutions. Understood, my dear children? Right.